Hello, my name is Jorge, and in this video I will briefly expose the main principles about motion control and the devices that are used for this purpose, focusing only in the motion control of 3D robots. First of all, we need to know what is motion control. Motion control is the field of automatics which is in charge of controlling everything related with the mobility of a robot using the dynamical model. The main points I am going to talk about are the dynamical model. Secondly, I will talk about the control objective. Then I will go ahead with kind of controllers, in which I will talk about the PID controller and the independent J controller. And lastly, I will mention the main application of the motion controller. So, getting started with, I will start with the dynamical model. The dynamical model is a method that is applied to get the input equation you need to program in your robot in order to perform some task. For example, if you want your robot to get from A to B, the dynamical model will use the Lagrange dynamic in order to get the signal you need to apply in your robot in order to perform that task. Now I'm going to talk about the control objective. The control objective can be summarized into trajectory tracking and compliance of regulation. What we mean with the trajectory tracking is that we need our robot to know where are all its components at each time. About the compliance of regulation, we mean that we must ensure that our robot does not exceed the security limit in order not to damage the hardware. I'm going to talk about the kind of controller. The first one is the PID controller. The PID controller consists on a method to get to adjust the signal in keeping it constant in order to avoid errors that could damage the hardware. The PID controller is composed of three controllers: the proportional, the integral, and the derivative controller. The proportional controller is in charge of the present error, while the integral and the derivative are in charge of the future and past error. Having all this information, the PID controller is able to reduce the error, uh, protecting the hardware from getting damaged. The second kind of controller is the independent joint controller. The independent joint controller works controlling the inputs and outputs of each joint of the robot. Uh, this controller gives us some simplicity, which leads us to some advantages, such as a better communication and a better scalability between the joints. Lastly, I'm going to talk about the main application of the controller. The first application is the tracking controller. The tracking controller is the most commonly used in industries, and it's used in all the fields of automatics. It works controlling all the parameters related with the motion of the robot. These parameters are the position, the velocity, and the acceleration of each one of its steps. The tracking controllers are used in all the fields of automatics and have uh, have very they are very important in some devices such as 3D printer machines or water cutting machines. The second controller I am going to talk about is the torque controller. The torque controller is used in order to control the torque of a robot. There are two controller systems: the computer torque and the computer torque light system. Now I'm going to talk about the adaptive controller. The adaptive controller works controlling the variation in some external parameters that influence the system. One use of the adaptive controller is in the aviation. For example, an adaptive controller would be the controllers that are used in order to measure the fuel of the plane in order to adjust the parameters for keeping the system working well. Now I'm going to talk about the robust controller. These are a variation of the adaptive controller and are used in order to keep a variable constant. For example, one of the applications is in self-driving cars, in which they are used to keep the speed constant independently of the mass that is in the vehicle. The last controller is the learning controller. This is used in self-learning machines such the ones that are in the logistic robots. And now I'm going to conclude summing up all the points that I have talked in this video. The first point I thought was the dynamical model, which is the method that is used in order to execute all the controllers. The second thing I talked in the video was the control objective, which I mentioned the trajectory talking and the compliance of relays. Then I talked about the kind of controller, which I mentioned the most important, which are the PID controller and independent controller. And lastly, I talk about the main application of the controller, which are the tracking control, short control, the adaptive control, the robust control, and the learning control.